Hello, everyone. Good morning. Good afternoon, actually. My name is Alessandro Pilotti, Cloudbase Solutions. So we are the company who does all the work related to Windows components in OpenStack, starting with Cloudbase-init, Hyper-V integration, and so on. So I will go through quite a lot of these components across this session, and then I will switch to containers. So I will explain what we're currently working on the container side, Kubernetes and so on. How many of you folks deploy Windows in OpenStack today? Okay. How many of you folks plan to deploy Windows in OpenStack? Great. Okay. Excellent. So the first slides that I'm going to go through are specifically for introducing how you actually do it, which are the key components, how you do it, and everything so on. So to begin with, Windows is a first-class citizen in OpenStack, so that even if OpenStack was definitely started by a community which is mostly Linux-centric, it doesn't mean that the operating system involved has to be only Linux, okay? So Windows is definitely fully supported, works perfectly well, and so on. There is no particular difference in image handling compared to Linux, meaning that you have glance, and you just use glance images exactly like you will do for Linux images. Formats, QCOW2, VHD, VHDX, whatever you prefer and whatever your hypervisor will support. For libvirt and KVM, specify the OS type in glance. Remember always, when you create the images, to sysprep them, okay? So that's a requirement from the Microsoft side. All right. Opa, other way. Whenever you run a virtual machine, you will need to have also so-called synthetic drivers, aka drivers that will be able to be optimized for the specific virtual hardware that you have in your hypervisor. As you know, OpenStack supports different types of hypervisors. So for example, KVM is the most popular one. Hyper-V is definitely supported. ESXi, Xen, and so on are all supported as well. And each one has its own set of different drivers. In the case of KVM, so the most common use case, Virtual.io are the drivers you're looking for. Otherwise, VMware tools, and server tools, and so on. For Hyper-V, the good news is that you don't have anything to do. It just works. Now, you can take a Windows image, just put it in OpenStack, it will just work, okay? But it won't have all the features that you're typically used to in Linux. For example, creating users, being able to run some custom workloads, performing, using heat templates to deploy some particular workloads inside of your virtual machines and so on. So, and that's usually performed on the Linux side by Cloud-init, okay? On Windows, we developed a project back in the day in which we started in all the work in OpenStack, so that was around 2013. We developed a project called Cloudbase-init, okay? Fully open source, fully available, and you can just download it from a website, okay? Also, the OpenStack documentation, whenever you go and look at the OpenStack documentation about info about how to create Windows images for OpenStack, you will find also Cloudbase-init, okay? It's extremely simple to install, traditional Windows installer and MSI installer. You start, next, 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 finish. That's everything is needed. Of course, it can be customized. There are a lot of options that you can use, but generally speaking, for the large majority of the use cases, this is everything that you need. At the end of the installer, it will even ask you if you want to sysprep the machine. So you don't even have to remember how it's done, okay? It will just do everything for you. Okay, forgot to update that slide. Now we have more than 30 million, actually, Windows deployments reported, so that's actually quite a large number. It's 100% Python code, so it's also meant not only to be friendly for Windows admins, it's also meant to be friendly for people coming from a Linux background, especially from a DevOps background, okay? We are OpenStack developers, so we developed it like any other OpenStack project, so fully Python and so on. It's wrapped as a Windows service, so it looks and feels like a natural component of your operating system. Works on any supported Windows version. Okay, we used to have support also for Nano Server, which unfortunately Microsoft decided not to bring on as a let's say, host operating system. It has a plugin-based architecture, meaning that it's pretty easy to extend with new features, and supports a large number of clouds. OpenStack, of course, EC2, Azure Stack, CloudStack, OpenNebula, MAS, GCE, Oracle Cloud, and so on. It has a pretty large number of features. For example, it sets automatically the host name for you. So whenever you spin up a VM, that VM will have a name. You will find the same identical name inside of the virtual machine. Username and passwords, that's actually very important. Whenever, unfortunately, on the Windows side, you typically have to deal with usernames and passwords, sadly. While on the Linux side, whenever you spin up a virtual machine, you typically pass a key pair, and you just log in with a key pair. So you don't have actually to find a way to share secrets like a password, right? So I will show you how also in Windows you do that by using a key pair and let Cloudbase-init generate a password for you. And Nova has a feature for retrieving that password. Other information, static networking, public keys, as mentioned before, automatic volume expansion. So meaning that if you start an image, which is, for example, 20 gigabyte, but the size of your volume, for example, is 50, Cloudbase-init will automatically expand the volume to the maximum size. So the main idea is that Cloudbase-init is pretty much invisible. So in the moment in which everything works, that's his job, okay? Other things, WinRM HTTPS listener, which allows you pretty much to run, for example, Ansible workloads, right? If you ever played with Ansible or ever used Ansible, you know that on Windows, well, on Linux it uses SSH, on Windows it uses WinRM over HTTPS. So this configuration is not only useful for doing PowerShell remoting, it's also useful for Ansible, and it comes out of the box. Okay, time service, time synchronization with whatever is passed in from the OpenStack side, automatic updates, send policy for the volumes, licensing, meaning that you can also inject a Windows license and so on. I mean, Windows product key, better said. It sets also NTP, it sets an MTU, if you have requirements, for example, for GRE or VXLAN tunnels at the host side, and so on. And very important, it allows you also to run user data scripts. You're surely familiar with the Linux side, in which you can pass in, for example, a bash script that will be executed on your virtual machine when it starts. The same thing happens here. We don't use bash, we use PowerShell, but the concept is the same. More details, you have a link over there. We have also full CI testing. Here are a bunch of components that we use. One is called Argus, Tempest-based Cloudbase-init CI framework, and Arrestor, which is a simulation of cloud metadata services, so we can actually, from the same test infrastructure, simulate all the various clouds we were talking about without having to duplicate the entire infrastructure. We test on every supported Windows version, 7, 8, 8.1, 10, and so on. And the same thing, of course, on the server side, okay, including the recent 1709 and 1803. Now, for a lot of people, it's much easier to just test out a Windows image before getting into the details about how to create one. So the easiest way to do that is to just download the so-called evaluation images that we still have on the website. You can find them at cloudbase.it/Windows Cloud Images, okay? Just download them, put them in Glance, and deploy your virtual machines, okay? Very important, you have to accept a license, which has been provided to us by Microsoft. This license says that you cannot use these images in production. So, very important, okay? Now, since those test images are only for, well, testing, how do you build your own? So here is actually the tooling that we use, the one that we use ourselves to create it for our customers and so on. Or even the images themselves that you saw in the evaluation copies. PowerShell, you just run it, specify some information on the command line, and it will just create the images for you. For example, you can say, look, I want an image for Hyper-V, for KVM, for bare metal, or whatever else, and this will take care of doing everything. For example, installing virtual drivers, running Windows updates, installing custom drivers, custom applications, whatever you might need, okay? Now, how do you run custom user data? The sky is the limit when it comes to user data, okay? Or the sky is the limit, of course, as long as it's 16 kilobytes. but there is quite a lot of data that you can put there. Plus, of course, you can also use that user data to download more scripts and so on. And plus, we support also gzipped user data, so it can be a pretty long script at that point. The way it works, you simply put PS1 on top of the first line. So Cloudbase-init knows that that's actually PowerShell, and then whatever PowerShell code you want to insert, okay? Also, for compatibility for the ways in which EC2 is doing it on Amazon, we also support this particular syntax, which I don't particularly like, but that's the way Amazon did it. So this way you can use the same identical script that you already use on Amazon. Some examples. The first line is just creating a user. Okay. There are better ways for doing that, but let's say this is something that I can put in a couple of lines. This is just traditional command line. The second one is an offline domain join. So of course you can also join your virtual machine to a domain directly out of the boot process and the provisioning that you perform with Cloudbase-init. And you can find also a ton of additional examples online. When it comes to orchestration in OpenStack, Heat templates is what comes to mind. Heat is also perfectly supported on Windows, thanks, of course, to Cloudbase-init in this case, which is able to interpret the user data, which is a multi-part user data that comes in during the boot via the metadata. Metadata which are provided through a specific magic IP, 169.254.169.254, or via config drive, which is an ISO or a vfat partition, which is attached to your machines, okay? All things that you don't have to care too much because Cloudbase-init does behind the scenes for you, okay? Here are a couple of examples how to create an Active Directory domain controller. Here is another one about how to deploy SQL Server directly via Heat template, okay? So you take the Heat template, you deploy it, and that's it, okay? Then, of course, you can go create more complex deployments. We have a lot of them, and you will find also a lot of examples there. Now, let's move on. Licensing. That's a topic that comes quite often up. The licensing is surprisingly easy in OpenStack. I would recommend to use a so-called data center license, which allows you to have unlimited virtualization rights, meaning that you pretty much have one license that covers the host, the physical host. Every VM that you run over there is covered by the same license. So you don't have to remember each one, okay? It becomes surprisingly cheap, okay, when you have, especially if you have a given amount of density. It works with Hyper-V, VMware, KVM, so you're not forced to use only an entire Microsoft stack. You can use any supported Microsoft, supported, let's say, virtualization stack, like, for example, VMware, KVM, and everything, in some particular conditions, as I will discuss pretty soon. Volume licensing is typically the best solution, so quality assurance and so on. Microsoft license itself, it's a topic that might require an entire day to discuss, so I will just limit it here. But let's say the basic concepts are exactly this one. If you run a public cloud, there is a specific licensing model called SPLA. While if you own, or your company owns, say so, the entire stack, then software assurance is what you need. Microsoft support for Windows VMs. Windows guests are supported on Hyper-V, so whenever you use Hyper-V, you're already set. Or SVVP, which is a Microsoft program called Windows Server Virtualization Validation Program, in which pretty much all the vendors in this space are present, Red Hat, Canonical, VMware, SUSE, Oracle, and so on. The main idea is that if the stack is there, you also get Microsoft support. If it's not there, aka if you created your own stack, for example, you deployed your own CentOS images or your own Debian images, and you have your OpenStack with KVM, and you run Windows machines on top of it with the open source virtual drivers, unfortunately, Microsoft won't support that particular scenario, okay? Okay, up. Does Microsoft support Hyper-V in OpenStack? So usually people say, Microsoft will never support Hyper-V in OpenStack. That's not correct. Microsoft supports it, absolutely. OpenStack is just a management layer on top of the operating system. So since everything that we did in Hyper-V with OpenStack uses documented APIs and APIs which are supported, then whatever workloads you run on top of it, among the ones supported by Microsoft, will also be supported. So that's pretty simple. There is also an alias, which is openstack@microsoft.com, where you can also write emails to Microsoft, and somebody can reply with additional info. Next. Let's move now from the guest operating system to the host, okay? Hyper-V is the Microsoft hypervisor, okay? It's a work that we started with Folsom back in 2012, so that's quite a long time if you think about it. It's very stable, very mature, and supports, let's say, every subsequent version of Hyper-V that has been released in the meantime. Does it require System Center? No, absolutely not, okay? The only thing you need are boxes running Hyper-V, nothing else. Some unique features, because people say, why should I use Hyper-V if I already have KVM? If you're happy with KVM, there is actually nothing wrong with that. Clear. Hyper-V has some additional features, for example, Windows failover clustering. A lot of time, companies come and say, users come and say, look, I have this virtual machine that I used to run on, for example, VMware, and VMware was take care of all the high availability for me. If I move to OpenStack, I know that if my KVM node dies, my VM will also die with it. Because normally when you work on a cloud, you have to design your workloads for clouds, right? It's the famous pets versus cattle scenario, no? Luckily, in Hyper-V, we support also the Windows failover clustering, meaning that if one node dies, your workloads will automatically be migrated and spawned in case on another node, okay? So you don't have to care about that, exactly like in the case of traditional workloads with a Windows cluster or with VMware and so on. That's a big advantage. Remote FX is another type of API which is available, allowing for, let's say, sharing host GPUs with a guest, but not assigning an entire GPU, okay? Not GPU pass-through. The idea is they can pretty much slice the GPU. For example, if you have 64 gigs of RAM, you can give 8 gig to each VM, and each VM will see a GPU inside, okay? That you can also use for any type of workloads that can run on a GPU, okay? Shielded VMs, and just to finish the remote FX, that's actually an amazing platform for VDI, because you can run your desktops and everything. Shielded VMs, it's another feature that allows you to have full VM encryption and isolation, and it's amazing for security. The main idea is that even if the host so even if a hacker manages to access the host, okay, the hacker won't be able to access the content of the virtual machines, regardless. That's a mixture of technology started with virtual TPM, encryptions, and so on, okay? I'm not entering into details because it's a fairly long, complex topic, but it's highly valuable if you're interested in a secure deployment. Okay. Hyper-C is the hyper-converged Windows server that we suggest as a recommended deployment option. Okay, it supports nano server, but of course also the full Windows server right now. Storage space is direct, scale-out file server, Hyper-V, Windows failover cluster, Open vSwitch. So the idea is that it's a fully hyper-converged deployment based on Windows. Think about storage space is direct. That's something that basically replaces Ceph in this particular context. It's very performant, uses accelerated direct SMB RDMA, so it's highly optimized, let's say, for this type of workload. The Windows Server release cycle. People get a little bit confused usually by how Windows got released after Windows Server 2016. Since then, Windows started a more flexible release cycle and also a more continuous one, okay? So instead of just waiting 3 years or 2 years or how much it is from one release to the other, Microsoft is releasing every 6 months a new release. The big difference is that the long-term servicing channel, LTSC, has a total of 10 years of support, full 5 with mainstream support and 5 with extended. The other ones, okay, Microsoft skipped one, so-called RS2, which was only Redstone 2, which was client only, while RS3 and RS4, named 1709 and 1803, from the month in which approximate month in which they came out, quite approximate, have a total of 18 months of support. So they're great if you just, are used to roll to the next version all the time. Think about it, something similar like Ubuntu does, no? You have like 1604, 1804, which have a long-term support, and the versions in between, they got released every 6 months, which have a shorter support time frame. Windows Server 2019 is also on the horizon, which also has a beta preview out there. Now, before switching to containers, how do you do networking with OpenStack in Windows? Well, the most common use case is to use Open vSwitch, because Open vSwitch is, how can I say, the lingua franca of networking in software-defined networking, okay? We ported Open vSwitch to Windows initially because we needed to make sure that if a user deploys KVM and Hyper-V, because you can have a mixture of KVM and Hyper-V nodes in the same OpenStack deployment, okay? So don't think that your OpenStack deployment has to be only Hyper-V or KVM. So at that point, we needed to make sure that the tenant was able to communicate across all those virtual machines, regardless of the fact that they were KVM or Hyper-V. It supports a lot of features. Tunneling, VXLAN, GRE, STT, Geneve. There is the neutral ML2 plus OVS agent just works as is. And most important, it's also supported with controllers like OVN, Open Daylight, NSX, and so on. OVN being our preferred one. It came a long way. Now it's in full stable release. Not only it works great for OpenStack, it works also great for Kubernetes, as you will see pretty soon. In a lot of cases, you might want to run some nested virtualization scenarios. Think about testing and everything. So Hyper-V has a full support for that, including a bunch of new features. How do you tell Nova how to enable this feature? Very simple. In the glance image metadata, set HW CPU features equals the VMX, or in the flavor extra specs, HW colon CPU features VMX, okay? So this was basically tell the scheduler to find, of course, a node that allows that, and the node itself will know that has to enable that specific feature. It's just a flag in the end in the virtual machine when it gets created, okay? Very simple. Okay, and now for something completely different. So things are changing a lot in Microsoft. One thing that has been included since some time is the so-called Windows Subsystem for Linux, WSL. It's amazing. It runs ELF binaries that is on Linux, okay? You take your Windows binary, x86-64 binary, it will just work. It has a different process model from the Win32 one. It's based on so-called Pico processors. Various Linux vendors' images are available in the Microsoft Store. It allows APIs, like for example Fork, that were never available in Win32, not even in Cygwin or MSys2. And we, as a company that ports a lot of code from Linux to Windows, we always struggle to the fact that whenever there is a fork, which is a very common API in a system call in the Linux world, we had to invent very complicated solutions to do that, including OpenStack itself. Microsoft now even supports AF Unix sockets, which is amazing because that used to be another nightmare when porting everything. One thing about naming, that's a funny thing. It's called Windows Subsystem for Linux, but in reality, what you have is actually the GNU user space components. So theoretically, it should be called GNU K-Windows, okay? So we stick, of course, with Windows Subsystem for Linux because it's much easier for everybody. But exactly for Linux, you have the GNU user space, and then they have the Linux kernel. Here, in this case, you have the GNU user space, and you have the Windows kernel. Other features, you have an enhanced session mode for Linux VMs that we will support also pretty soon also in OpenStack, allowing you a lot of extra features when you have the console, the VNC console or the FreeDP console that you have in the Horizon interface. Okay. Now, here's another thing which is extremely interesting. Microsoft used to have one hypervisor, Hyper-V. Still has one hypervisor, but the main idea is that there is a separation now with the hypervisor itself underneath and what we call a Hyper-V at the moment. This hypervisor underneath is called Windows Hypervisor Platform. Think about it like you will have a KVM and QEMU in the Linux world. KVM is a kernel module. QEMU takes care of everything on top of it. In practice, it allows you to run QEMU on Hyper-V, or better said, on the Windows Hypervisor Platform. the funny thing, or the great thing, is that now you can also run Hyper-V VMs and QEMU VMs side by side. And also, very interesting, the actual VMs will use virtual drivers and not VM bus-based ones. So you don't have the Linux integration services. The same identical VM that used to run on KVM can run as is on top of the Windows hypervisor platform. Quick demo. As you can see, you have an Ubuntu starting. Behind it, you can see the Hyper-V console, and you can see that there is the Hyper-V manager, and you can see there is no additional VM that started. So those are Hyper-V VMs. This is a QEMU VM, okay? Just going to show you a quick difference between the Hyper-V ones and the QEMU ones. It will take another couple of seconds, I think, for finishing the boot. And just to make it clear, I won't demo it right now, but one of the use cases that we demoed at Build a couple of weeks ago was the fact that the Android emulator, which uses QEMU behind the scenes, now runs directly on the Windows hypervisor platform, aka Hyper-V. No need to use Hexam or additional or alternative options. Okay. So what I'm doing right now is running a tool that we use all the time to determine where and what hypervisor we are, and which is actually doing a CPU ID call and which returns information. And as you can see, the string is different from the one that Hyper-V will return. Now, this might not be the final one. Currently, we are merging dispatch upstream in QEMU. But the idea is that normally you will have a Microsoft HV here, and here you have a completely different one. So you can see that you're running in a completely different space. I could start a Hyper-V VM, but I won't because I have a lot of other demos to show. And you will see that there is a clear difference. OK. Now. Another important feature in Windows is the fact that now Windows supports containers, OK, since actually a couple of years. The idea is that there are Windows containers and Hyper-V containers. Windows containers are traditional containers. Same Windows build as the host, less isolation. So take care, you cannot use it for multi-tenancy and stuff like that. Hyper-V containers are used, on the contrary, for isolation. More lightweight than full VMs, but still a little bit heavier if you want than containers. How do you run one or the other? Simply, in Docker, you specify -- isolation equals Hyper-V, for example, for having a Hyper-V isolated one. Docker now on Windows can run both Linux and Windows containers side by side. You can specify, if needed, the platform, or you can also set the default one. So the daemon will know which one to spawn, okay? It's called LCOW, where COW doesn't stand for copy and write, stands for Linux containers on Windows, okay? Okay, and here is one of the main topics I wanted to discuss today, Kubernetes on Windows. So this is part of the big work that we're doing today as part of the Kubernetes community. Kubernetes on Windows is supported since 1.9. When I say Kubernetes on Windows, I mean kubelet kubeproxy, so the master is still running typically on Linux. There is no particular reason to run it on Windows. The idea is to have supported clusters with a mixture of Linux and Windows nodes. So that's the goal, and actually that's what I'm going to demo. Improved support in Windows Server RS4. There is a lot of new stuff coming, so Microsoft is investing a lot on the platform for that. And we as a community, we are also adding all the components on top. Support for multiple network plugins, including, of course, OpenVSwitch. Here is the general architecture for OpenVSwitch, which I won't be able to get into details right now, but it's the same one that you have on Linux. So it's based on OVN controllers, northbound, southbound, and then the corresponding components also on the individual nodes. I'm sorry, the nodes are here, while the master is here. I leave another slides, which are more technical, goes more into details. I won't be able to discuss it right now, but since I will share also the slide deck, it's available for everybody to download and take a look. Okay, Kubernetes. So if I do, take a look here. So I have two nodes, one Linux, one Windows. Where are those living? They are living on my OpenStack environment, which is here. Here, technically here, as in at the Cloudbase booth. If you can believe it, since I cannot directly connect to it, I'm doing a VPN back to the office in Europe, and then reconnecting back to the thing. So there will be a little bit of latency, like around 500 milliseconds anytime that I try to type, but it works. So you can see that there is a Windows node, there is a Linux node, there is a master and everything. So this is another example. Each one has its own IP, but doesn't really matter. This stuff runs actually on a hyper-converged OpenStack deployment, which is sitting on the table on a bunch of Intel NUCs, which are deployed via MAS, okay? So you can see them here. So I could actually technically power them off from here. Right, so. Now, let me do first one thing. I'm just creating a bunch of pods. So you can see that I have a mixture of them. One of them is a nano server image. The other ones are, this one is a Linux one running Apache, and the other one is running Nginx. So we have three of them, one running Apache, Nginx, and IaaS on top of Windows. And on top of it, we do also load balancing via OVN. So if I do an OVN nbctl list load balancer, I will see all the information about how the load balancing is actually configured by OVN. OVN is setting all those rules directly on the Linux and the Windows nodes. I can see here, for example, this is going to be the port that will be exposed on the node in this case. We can also add an additional load balancer in front. So in this case, it's a simple deployment in which we use just one node as a gateway in particular. As you can see, they're up and running. Ignore that one in between, which has nothing to do, is there since before. But you can see the Nano one is running, and the Nginx one running, and the Apache also. If I go on my node, and I do a Docker PS, I will see a bunch of containers, including the one specific. So this one's called OVN Kubernetes pose. It's just a pod container that we use for internal, let's say, during the deployment. And then you can see also the one specific for our deployment. That is on top. All right, let's see how we stand of time. Okay, we still have a bunch of minutes. I want to show you now a few things. How many of you folks do Kubernetes, by the way? Okay, quite a few hands, okay. So one thing that we worked on is helping users getting into Kubernetes and understanding all the tooling which is needed for actually creating application for Kubernetes. Because Kubernetes can be complicated to learn. You have to learn Docker files. You have to learn the manifest for the resources. Then if you want to package them, then you have to learn how to write Helm charts. And then you might want to have scaffolding for that. So you have to learn also how to write draft packs. So it takes quite a while. No? So why not simplifying everything? One of the things that we did is a Visual Studio integration. So for example, I can create a new project. In this case, it's going to be an ASP.NET Core 1 running on Linux. I just do basic actions, like creating it with basic information, model view controller, okay. And this is creating on Visual Studio just a solution, including the project and all the data, okay? Visual Studio 101 here. Now, I can, from here, directly deploy Minikube. Minikube is for Kubernetes what DevStack is for OpenStack, okay? It's basically a one-node Kubernetes cluster running entirely inside of a virtual machine. Usually it can be a bit complicated to deploy. In this case, one click, you deploy Minikube directly on your machine. Windows 10 or whatever, you can run it. But also very interesting, I can right-click here, add Kubernetes support, and this will automatically add all the scaffolding via draft for the Helm chart and also the Docker file. Now that I can do my changes, do whatever I need and everything, and I can choose the Kubernetes cluster that I want. Okay, here I have two configured, okay? One of them is running on an Azure cloud, but it could be on OpenStack or wherever else. And now I can do deploy to Kubernetes. This is a Visual Studio extension, which is, of course, open source, okay? It's called VS Kubernetes. Now, it will take a couple of minutes because it has to create a Docker file, push it up in Azure, and so on, okay? But as you can see, we didn't have to learn and do anything to do this. It just works. Since all the files are here, for example, our Docker file is here, all the scaffolding for the charts are here, and so on, I can just go in and do whatever changes I want, okay? This is still, as you can see, the logging here is under development. That will be the spinning bars, but you get the idea. Okay. One of the interesting things, of course, with Kubernetes on Windows is that it's, as I mentioned before, in beta, so still there is development going on and everything. But the goal is to integrate it also in any common situation in which you might want to deploy a cluster, okay? So for example, OpenStack will be, of course, one of the core areas in which we want to invest. In this case, the demo that I showed before is running directly on OpenStack, okay? But the idea will be also to automate the entire workload. At the moment, that workload is automated via some Ansible playbooks, okay? So you can just download them. They are available in the OVN Kubernetes repository. Should be almost there. Let's see where we are. I can show you also a bit around here how the charms work. So these are automatically created via a draft pack, as I mentioned before. So all this scaffolding comes in automatically with all the information. For example, you can define how your Helm chart is called. Helm, as I mentioned before, it's a very popular packaging solution for Kubernetes. I would say the packaging solution, okay? It's great to basically package your applications in a way which they are very easy to distribute and deploy. Here you can have some values, information, for example, what port you want to expose, and so on, how much memory should have in terms of limits your container, and so on. Let's see where we are. Here on the template side, you find also rules, for example, for ingress. You see that there is a templating language here, so that basically will include or not define features based on what you have. And here, your deployment YAML. So all those things generate all the information that is needed to deploy your application. Kubernetes people really like YAML, in case you didn't notice. Okay, It worked. Our application is now on Azure, on a public cloud. So if I do an Helm list, I can see that it's created over there, okay? And if I do a kubectl get pods, I will see also my pods coming. There you go. Okay, I have 2 of them on a replica set. Okay. Last but not least, I can also debug my application directly in the cloud. Meaning that with Draft has a feature called Draft Connect that basically creates a forwarding locally, and I can connect to remote debugging to my cluster actually running in the public cloud, okay, or wherever your Kubernetes cluster is running. It's connected. This is the port which is forwarded locally. This is my actual application. And if I go and set a breakpoint, for example here, and I hit, for example, my About button, you will see that, voila, I hit the breakpoint, okay? So I can fully debug it. This thing is not running on my machine. It's running directly in the public cloud. So the idea of doing this work was to help people in getting used to Kubernetes. Similar efforts are going on VS Code and so on, okay? All right, do we still have a couple of minutes for questions? We are over time, okay. Well, I will be available for any type of questions out here. Thanks a lot for attending.